All right, guys, due to some demand, I'm going to go ahead and solve for you question 7 and 8 on page 598. So it's a punnett square dealing with two heterozygotes, and it's a dihybrid cross, meaning that there are two alleles that two genes that we care about. So it says, in fruit flies, long wings, capital L, are dominant to short wings, and gray body color, capital G, is dominant to black body color. Flies that are heterozygous for both traits are crossed. Okay, so here are the genotypes of our parental generation. They're heterozygous, meaning they have mismatched alleles for L, and they have mismatched alleles for G. Great. First thing you do whenever you do a punnett square, I've got here, look, it's a 5 by 5. I'm going to be putting the gametes in these outside parts. And then the 4 by 4 square is going to be where we actually do our punnett square. So ordinarily, if you were doing this by hand, you'd get your 4 by 4 and then you just write your allele combinations for the gametes up top. So let's go ahead and start that off. I'm just going to fix that. There we go. I tweaked that line by accident and it was bugging me. Okay. So first thing we need to do is determine the possible alleles of the gametes. So in other words, what combos of gametes can this individual make? Now we're assuming, and we'll see something different a little bit later on, we're assuming that these genes, the L gene and the G gene, are on different chromosomes. In other words, we're assuming that they're going to be subject to independent assortment. So that means that if the big L allele goes to one gamete, that means the little L allele has to go to the other. And if the big G allele has to go to one gamete, then the little g has to go to another. Remember what you saw in the video from the amoeba sisters. You cannot have a gamete that looks like that, because that means that the offspring from this gamete, if it was going to do some fertilization event, this is not carrying a G gene at all. So that's most likely going to be non-viable. So let's detail the four possibilities. We have big L, big G. Remember, we're doing FOIL. So in essence, we are going to be figuring out all four possibilities, all four ways of having an L and a G together. So one way of doing that here is to have a big L and a big G. That's the first part in FOIL. Then we're going to do outside, which would be big L, little g. Then we do inside, little L, big G. And then we do little L, little g. So those are the four possible genotypes for the gametes. So I'll write them in here. And since this guy down here is also a heterozygote, that means that we can just use the same one again. So big L, big G, big L, little g, little L, big G, and then finally little L, little g. Now we're going to populate our punnett square. So in order to populate the punnett square, since I'm writing this on a computer, I can move the letters around as I see fit. The general way that we do it that has been kind of agreed upon by scientists is if you have a dominant allele, you write it first. So in the case of this guy, the L's would be both lowercase, but you would not want to do it this way. You always want to lead with the dominant allele. If there's a big uppercase letter in your combo for G's, you put that first. If there's a big L, you put that first. So I'm going to keep the L and the G in the same order that they were, but I'm just going to make sure that I pay attention to whether it's a lowercase or uppercase letter. So here we have LLGG, and I just realized I'm going to have to probably shrink down the text just a smidge. Beautiful. Then we have L, big G, little g. And we have big L, big G, big G. Then we have big L, big G, little g. And we just go through and complete all these. L, G, G. Big L, little g, and the last one, little L's and little G's. Okay, so here is our Punnett square. As you can see, there are a whole bunch of different possible, genotypes. And what we're going to do is take a look at the phenotypic ratio of all of these. Now we could do the genotype ratio. In other words, how many big L, big G are there? We can count all those out individually. For the purpose of this question, it's not necessary, but what we really do care about are the phenotypes. So I'm going to go ahead and I'm going to go through all of these, and there should be 4 possible phenotypes. One of them would be, well, they're right on the book, long gray. There's long gray, there's long black, there's short gray, and there's short black. The genotypes of these, for an individual to be long, it has to have a big L. For an individual to be gray, it has to have a big G. So that means that as long as there is one big L and one big G, the phenotype of the fly is going to be long-winged and gray-bodied. Then here, the genotype would be, long carries a big L, and we don't really care what the other copy of the gene is, right? Because if it's got a big L, boom, it's long, because long dominates short in this system. And then for black, the only way to have black-bodied is to have lowercase g for both. Remember, for a recessive trait, the only way to have that trait show up is if you have 2 recessive alleles. It's weaker, so the only way for it to show up is to have 2 of the recessive genes. For short gray, we're looking at little l, because that's how we get short. And then for gray, we need a big G, and we don't care about the other allele. And then for short black, the only way to do that is to have recessives for everything. So now that we've done that, I'm going to go ahead and, I'm going to start color coding these. So the long gray, I'm going to color code in maroon writing. So I'm going to go in here, and wherever I see a long gray fruit fly, there's one, there's one, there's one. Here's one. It's heterozygous for both. Here's one. It's got a big L and a big G. That works. Here's a big L, big G. So this guy has to be maroon, and this one has to be maroon as well. Sweet. I think that's, oh, wait. This guy's big L, big G as well. Boom. And this guy's big L, big G. Boom. So let's move on to the next one. We need a big L and no big G's. I see a couple here. You're always going to get, if you cross heterozygotes, you always get all possible phenotypes. So let's call this one, or let's do this one in, I don't know, green. So here's a big L with little g's. Here's a big L with little g's. That's not the same color. That's not the same color either. Here's big L with little g's. And I think that's all there is for the big L little g, the long black fruit flies. Now we'll go to the short gray. And let's do like a mauve or mauve or whatever you want to call that color. And there's 3 of them. So there's one here. There's one here. Oops. And there's one here. And then finally, short black. I'm just not going to color it. Done. So there's only one of these. So since there's 16 squares in our punnett, we have to have our fractions out of 16. So I'm going to get my marker out. And we have out of 16, 1, 2, 3, 4, 5, 6, 7, 8, 9 are going to be long and gray. So let's see, what fraction would that be? Or sorry, what decimal? 0.5625. Remember, we always do probability in decimal. Yes, if you think about percent, if you got 9 out of 16 on a quiz, you'd have 56.25%. But we don't do the multiply by 100 unless they ask us for a percent. Okay, for long black, we got 3 out of 16. For short gray, we got 3 out of 16. And then for short black, we got 1 out of 16, which is, I think, like 2.5 or something like that. Sorry, 6.25. So this is 0.0625. And then our 3 out of 16s are 0.1875. So 0.1875. Here's a handy thing that you probably knew already because you know how to do math a little bit. Since all of these together represent all of the possibilities, all of our fractions here should add up to 16 on 16. So 9 plus 3 plus 3 plus 1, that's 16 out of 16. So for the questions, they say, okay, what are the if you have 256 fruit flies that were born from this cross, how many of each would we expect to have each set of traits? And I think they're in the same order, so that I did this. So long gray is A, etc. So when you're given a number, like 256 offspring, what you want to do is multiply by the probability. So we'd go 256 multiplied by 0.5625. And same deal with the others, so 256 times 0.1875. Ditto here, and then 256 times 0.0625. So I have to do a little bit of number crunching, but it's not going to be that hard. So 256 times 0.5625 is 144 offspring. And then these guys will be 48. And then 256 times 0.0625 is 16. So 16 offspring we would expect to be short-winged with the black body. And again, if you add all of these numbers up, I mean, you should not be surprised, since all of these these decimals add up to 1, and all of these fractions add up to 16 on 16, which is 1. All of these values should add up to 256, and you can add them together and check it if you want, but I'm going to tell you that for sure they are. So that's question 7, and that sets up a whole bunch of stuff. Also sets up question 9, which I'm not going to do for you, but I am going to do question 8. So for question 8, it says, imagine that you randomly select one of the long-winged, gray-bodied flies from the offspring described in 7, and you do a test cross with a homozygous recessive for both traits. So that means that we're going to pick one of these guys. And it's asking us, what is the chance that the offspring will be produced in the ratio 1 to 1 to 1 to 1? This is a tricky question, but I mean, not entirely. So first of all, we have to look at all of our long-winged, gray-bodied fruit flies. We've got 9 of them. Now, I'll give you a little bit of a hint. What's going on here is they are asking us, and I'm going to get another 5x5 table up and just fix it up for us. There we go, beautiful. What they're asking us to do is they're asking us to take one of these flies, one of the ones that's in maroon, and cross it with a little l, little l, little g, little g. So the first thing that I'm going to do is I'm going to put out the gametes for our little l offspring, or sorry, fruit fly. So of course, remember, you always have to have one copy of each gene, and this poor guy really can only give one kind of gamete. It's only capable of giving a lowercase l, because that's all it's got. It's only capable of giving a lowercase g, because that's all it's got. So now we have to think about the different genotypes that we have here. And so I'm going to go through these. I'm going to do kind of a guess and check, but it doesn't have to really be a guess and check, because there's only a couple of genotypes that we have to look at. We only have to look at 1, 2, 3, 4 different genotypes. And right off the bat, you're going to see a pattern. Now, I'm not going to actually fill in the Punnett square for big L, big G, big G. Here's why. If I can only give a big L, then every single one of my offspring is going to have long wings. So that completely trashes the possibility that this one's going to work for me to make a 1 to 1 to 1 to 1 ratio. I hope you understand that, because this guy's going to give big L no matter what, and since this one gives little l no matter what, all of the offspring will have a dominant phenotype, which doesn't help us. Likewise, this one's not going to work for us because it has two big L's. This one's not going to work for us because all of the offspring will have long wings. This one's not going to work for us because all of them have gray bodies. So you can't get your 1 to 1 to 1 to 1. This one doesn't work because big L's. This one doesn't work because big G's. The only genotype that is going to get us what we want, which is all 4 phenotypes is a heterozygote. So instead of doing a guess and check, I guess I kind of spilled the beans. But we can logic it out. So I'm going to do a heterozygote, a big L, big G, little g. So here are the possible genotypes for the gametes. There we go. Those are all 4. Now we can go through and, oh, here's something else that's really nice. Look at this. Whatever I put into this square is going to be whatever I put into this square, and the same as that, and the same as that. All of them will be the same. They're all going to be heterozygous for both. That's great. Saves work. Here, we're going to have big L, little g, and wouldn't you know it, oops, it's going to be the same for all those. Now we have little l, big G, little g. And those are going to be all the same. It really helps because this test crosses with you always do a test cross with recessives. So it really simplifies things. And then all these are going to be little l, little g. So if we want to color code these guys the way we did before, all of these will be maroon. All of these will be green. All of these will be mauve or periwinkle or whatever you want to call it. I'm not good with, oops. I'm really not good with colors apparently because I'm clicking the wrong ones. And the last ones will be white because I didn't bother to color them. So look, we have 4 out of 16, 4 out of 16, 4 out of 16, 4 out of 16. What's the simplest ratio here? Amazingly, 1 to 1 to 1 to 1. So the only way to get this to work is to have a heterozygote, one of these. So the question is really asking us, and this is a doozy, what's the probability that one of your long gray flies will have offspring that do this pattern? Well, how many long gray flies are there total? There are, 9. And how many of them have the genotype that lets us do this? 1, 2, 3, 4. So the possibility or probability of picking a random long gray fly and getting this pattern in the kids is 4 on 9, which is 0.44. It's actually 0.4 repeating, but there we go. So this is how we tackle some of these questions. Question 8 is probably one of the most difficult questions because it really requires a lot of abstraction. So I hope that helps you guys out a little bit. Remember, please, if you have questions, comment on the assignment itself, not your assignment, the one that I posted. So it does not send me an update inside of Classroom, or it doesn't email me anything if you send me a private comment on your Google Forms that you're working on, or Google Docs or whatever. So please ask your question in the actual stream, the main page of Google Classroom. All right, guys, remember that stuff is going to be due on Thursday. I'll even try my hardest. I'll be checking emails on the weekend, but I'm not going to be on my email all day, but I'll check them on the weekend just in case you guys need extra help, okay? Oh, also, congratulations on graduating. Sorry it's not fun, but you still did it. You guys can save the party for when all of this mayhem is done.